All right, I just want to walk you through a few free fall problems. That way you have an example while you're doing your homework, labs, and study guide. When we're talking about gravity, we will, instead of this formula, we can say it this way. You can say dx for horizontal, dy for vertical. I don't care. You can say height. The difference is the direction, obviously. Height would be 1/2. And if you're vertical, the acceleration becomes the acceleration due to gravity. That is what accelerates everything downward, t squared. Now, on Earth, okay, the acceleration due to gravity is 9.8 or 9.81, depending on how you're taught. We'll just use 9.8 meters per second squared. That is on Earth, at sea level, in a vacuum, or ignoring air resistance. The acceleration due to gravity is roughly 9.8 meters per second squared. So let's say we drop a ball from a height of 10 meters, okay, and we time it, and it takes 1.43 seconds to hit the ground. So we can come up here, h 1/2 g t squared. This is the same as we did solving for A after the motion lab. It's the same math, just different numbers. So our height would be 10 meters. That would equal 1/2. We're solving for the acceleration due to gravity, 1.43 seconds, but we have to square that. So we've got 10 meters equals 1/2 our g, 1.43 seconds squared is 2.0449. I'm going to write all that out, and I'll tell you why in a minute. 2.0449 seconds, and then close my parenthesis. My seconds are squared. I leave everything in my calculator. If you were doing this and you wrote 2.04 or 2.045, that is okay too. Just know your answer would be just a little bit different from mine. I am not going to mess with significant figures or anything like that. I leave everything in my calculator, and so that does change my answer just a little bit. If you're rounding as you're putting these in, that's going to make a little bit of a difference. All right, so now I'm at 10 meters. That's going to equal 1/2 times 2.0449 seconds squared. So I got 0.02245. I'm not getting any better. You do not have to write this. You can say 1.02 is fine. Seconds squared times g. Again, we're going to divide by what is in front of the letter. Two, 2, 4, 5. Okay, and my g is going to equal 9.78. 0.429, but 2 decimal places is a plenty, meters per second squared. And I can round the 9.78 to 9.8 meters per second squared. So that's pretty close to the acceleration due to gravity on Earth. Now, another thing you can do is I could say, let's drop a ball from a height of 5 meters. And what if I just want to know how long it takes to hit the ground? All right, again, we can use the same formula. unless I say we're on a different planet, assume we're on Earth, okay? I know some of us would probably like to leave Earth right now, but unless I say we're on a different planet, assume that we're on Earth. And if we're on Earth and we're talking vertical motion, that's something you need to consider is the direction of the motion with every question. You know that you can use 9.8 meters per second squared. Unless I tell you to account for air resistance, assume it is negligible. So again, we would say 5 meters, 1/2 times 9.8 meters per second squared times t squared. So I'd have my 5 meters. 1/2 times 9.8 is 4.9 meters per second squared times my t squared. Divide by what is in front of the letter, meters per second squared, 4.9 meters per second squared. So t squared would equal 1.02. Now, my meters would cross out, so I'd be left with 1.02 seconds squared. Now that is t squared. So to get rid of the square, we need to take the square root. So if I take the square root of t squared, that makes it a t. And if I take the square root of 1.02, that is 1.01. My seconds, they were squared. If I take the square root, I'm just left with a second. So I'd have 1.01 seconds. Now you can do the same thing if given time. You drop a ball, and let's say it takes 3 seconds to hit the ground. What height did you drop it from? Again, unless I say otherwise, let's assume we are on Earth, and the acceleration due to gravity is 9.8 meters per second squared, and we're going to assume air resistance is negligible. So, same stuff, just solving for a different letter. So we're looking for height. So in some ways, this one is easier. 9.8 meters per second squared. And my t was 3 seconds, and I have to square my t. So my height is 1/2 times 9.8. I'm not going to skip steps. You can combine these. I'm not going to. 3 squared is 9. I got to square my seconds. These will cross out when I do the multiplication. So my height is 44.1. Because my seconds crossed out, I am left with meters. That's good because that's how height is measured. So my height would be 44.1 meters.